This recording will cover part 2 of chapter 11 from your textbook, and like I said, a lot of additional strategies and slides are in this second part. So another strategy, I don't really know that there's a name for it, but there should be. But you could teach this. Read the problem aloud. Look for important words and circle them. Draw pictures, use manipulatives to tell what's happening. Write down the math sentence and write the answer. So an example would be, okay, read the problem. You have 7 toy cars. Look for important words and circle them. Oh, I'm going to circle 7 toy cars. I'm going to circle 2 more. I'm going to circle in all. I know I'm going fast. Draw pictures. So here's a couple cars. You could draw some more cars and then write down the math sentence and write the answer. So you would write 7 plus 2 equals 9. It's a really good strategy. And again, I feel that there should be a name for it, but there's not. Some other ways to improve math performance, thinking self-instruction, self-talk. You model how to compute the problems. You compute the problems together. They compute them alone. That model, right? I do, we do, you do. You could be very explicit. When I'm solving a problem, first I need to da, 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 da. Okay, you could teach students to identify relevant cues in the problem. You could make sure you're providing corrective feedback and breaking down skills, into smaller parts to help them reach their problem-solving goals. You also want to think about focusing on real-world mathematics, right? Managing money, interest on loans, credit cards, taxes, employment form, job skills, adulting, all those things. But that's what they're going to need to learn, and these functional skills are often, not really there in the general math curricula. So thinking about how you could incorporate some of those things. Okay, some other functional math instruction for students with disabilities, consumer skills, making change, stuff like that. Comparing costs, thinking about, okay, what does it mean if something is on sale for 40% off? Homemaking skills, measuring, budgeting, calculating size, weighing themselves, caloric intake, auto care, home care, all of these things, leisure activities, transportations, all of these real world mathematical skills are so important and sometimes lacking from the curriculum. Also, current curricula sometimes it's pretty hard, right? Sometimes there are a lot of hard words that our students with behavioral problems or learning problems, they're going to give up. They're going to say, oh, this is too hard. I can't read this. Forget it. I'm shutting down. I'm going to hit my friend so I get kicked out of math class. Okay, there's also poor sequencing of procedures, in the textbook. Multiple concepts are introduced in one lesson instead of just teaching them one concept at a time and then kind of putting it all together. They maybe give you 2 problems to cover a concept and think the students can master it from that. Some of the pages are way too confusing. There's way too much stuff on a page. And the textbooks assume that students have prerequisite skills for given tasks that they may or may not have. So you want to think about what really works. Oh, by the way, any of these slides that are kind of different color, those are the ones from the presentation that I did, okay? So you want to think about using CRA, concrete representational abstract. So concrete demonstration or manipulatives, right? Actually holding 3 apples. Then maybe some representational or pictorial depictions, 3 tally marks or pictures of apples, and then the abstract depictions of problems. So just knowing that what 3 means. So that is that CRA instruction. Okay, we also want to think about, using explicit instruction. We've talked about that, modeling, guided practice, independent practice, examples, and we talked about this in chapter 10, non-examples, especially in math. Okay, manipulatives, of course, are very, very effective at all ages, even some of your older students. There are a number of strategies. There's Solve It, which is a 3-step process where students coach themselves. Then there's Say, Ask, Check. Say the purpose of the step, ask what is required in that step, and check to assure the step is completed. Some other things, some other strategies that work. Engagement. How can you get students engaged in math? Okay, this one's a good one. Learner.org/interactive/daily math. I know you can't click on that. You can't click on it here in the recording, but if you go back to the oh no, just copy this and put it into your browser if you want to use this. Thinking about allowing students to make choices about their math learning. Thinking about ways that they can show you what they know and ways that they can access math. Ways that they can show you here, output, and then assessment, formal, informal, authentic, concept maps to assess student progress. Think about in chapter 10 when I talked about those Frayer models and those vocabulary maps. Use that as an assessment. Maybe you give them the term and they have to fill out the rest of it. And that's a really simple assessment for you to give to them. All right, a couple more jokes. Why was the math book so sad? Because it had a lot of problems. And why do middle school girls walk around in groups of 3? Because they can't even. I just thought those were fun. All right, so a couple more mnemonics. LAP, this is for adding and subtracting fractions. Look at the sign, ask yourself, are the denominators the same? And then pick the process for the fraction type, which of course you would teach them all these processes, right? And then solve, study the problem, organize the facts, line up a plan, verify your plan with action, should say your, not you, your plan with action, and evaluate your answer. Okay, there's also some discussion questions that you could use. So you want to think about open-ended discussion questions, especially in math, not just, one that has a right or wrong answer or one that could be looked up. And this is geared towards virtual, virtual learning, virtual students, but same thing in your classroom. You could ask things like, what do you think? Why do you think that? How do you know that? Can you tell me more? So open-ended questions. How can you solve that problem? Here's the problem. Tell me one way that you could solve that problem. Oh, great. Okay, next student, you tell me another way you could solve that problem. So leave the questions open-ended so it gives them more, it kind of forces them, right, to talk more about math. So again, open-ended question, stuff like this. They could give an example of a concept and explain why they think it's a good example or non-example. We've talked about that, right? They could talk about current events, sports, cooking, whatever's interested. The Great British Bake Off, right? If some of your students are interested in that. You could ask them things like, what would it be like if there was only one way to solve a math problem? And then again, talk about multiple solutions and getting them to explain their thinking. Okay, you could have a virtual debate. The SAW strategy, which we haven't talked about, is the best strategy for problem solving. Do you agree, disagree, why, or why not? You could also have them come up with some predictions, give them a math situation, they predict the outcome and explain why. Some other things you might want to think about are some critical thinking question prompts. So, yes, some of them are not necessarily related to math, but how could you relate these questions to math? How would you solve blah, blah, blah? How would you use this? Give an example of this. Describe what this. Would it be better if we only had one way of solving math problems? Why do you think that, right? What would it be like if, can you elaborate on the reasoning? So using some of these these critical thinking questioning prompts. Okay, some other ideas, and a lot of you probably use all of these ideas or have seen some of these. Padlet, Pear Deck, Nearpod, breakout room, stuff like that, choice boards, where they would have to choose, that's up on the whiteboard. They choose one from the left column, one from the right column, and they must do one in the middle. I actually saw that in a second grade class in Florence a few years ago when I was supervising a student teacher and just thought it was great. Again, forget about asking dead-end questions, right? We want them to have some open-end questions. Some virtual games or face-to-face. Of course, if hopefully we stay back face-to-face, but if students are virtual, you could just email them stuff like this ahead of time. This is a game, you can just Google it. It's called I Have, Who Has, and there's tons of variations of this game out there. So you would just, if you're face-to-face, you would start, I have 81. Who has 5 times 6? Then they would have to think, the person who has the card would say, I have 30. Who has 7 times 7, right? And you would just kind of keep going. And ultimately, the question they would say, I have blah, blah, blah. Who has 9 times 9? Oh, and look at that. It would come right back to you. Okay. But you can just Google I have, who has. Another thing that I used were think boards, either virtually or in face-to-face. So you would come up with a solution that can have many questions or problems. So this one says the answer is ... 12 more dogs. So that's the solution. So then all these little cards, and I know they're really hard to see, those are the questions or the problems that give you this solution. So you could have one person or you could come up with a solution and then have all the students come up with a variety of questions and problems. Okay, so you could put something like the answer is, you'd write your answer, and then the other students would think about ways to get to that solution. Example, I had 18 dogs. I had to give 6 of them away to my friend, which is just very sad because who would want to get rid of 6 dogs? How many dogs did I have left? All right, so you could do something like that. If students, if we ever go back to virtual learning, you could do something where you post each answer as a whiteboard or discussion prompt in the breakout rooms, and then they rotate through the breakout rooms. All right, I'm going to spend a few seconds talking about manipulatives. The ones I'm going to show you are pretty much for fractions, but of course there are thousands of manipulatives out there. There are also virtual manipulatives. I think it's out of University of Utah, I think, but if you just search virtual what is it, library of virtual manipulatives. There are tons of options, and hopefully you have heard about that in some of your math classes as well. So here are some fraction manipulatives. I know they're kind of hard to see, but you know, there's one half, one third, one third, one third, and it's really helpful to talk about equivalent fractions using something like this. There's also, oh, I skipped one, sorry. You could also make your own with sentence strips, right? One half, something like that, or you could do something like this. You know, if you had sentence strips, just do one or whole, half, fourth, right? So you could very easily make your own. All right, so I want to show you, this is so cool. Okay, I just discovered this and it's the coolest thing ever. So these are written on like popsicle sticks or you know, the fat ones, like the tongue depressors. And so what you would do, you'd write, okay, 3/5. Here's your fraction, right? And then here's all here, so your fraction is 3/5, even though up here it says 3/4, but that's okay. And then here are your equivalent fractions, 6/10, 12/20, 18/30, stuff like that. So you would have this, okay, so this is kind of one set, 3/5. And then you would, oh, and I lied, we're not using 3/5, just kidding. So now we're gonna do 2/3 and 2/5, okay? So you're gonna write these numbers on, and let me just show you what mine kind of look like, right on kind of these fat, popsicle sticks or tongue depressors, whatever you want to call them. So you write them down, you write the numbers over here, 3/5, and then here's your equivalent fractions, and they could kind of slide along or move along until they found an equivalent fraction. How fun is that? Okay, so let me go back up here. So you have 2/3 and you have 2/5. So you write down all of the fractions, you know, as much room as you have. So I had to work really hard on the ones that I just showed you. And then what you would do, you would slide the fraction 2/5 over, wait, excuse me, I lied. Look at the denominators of each fraction, okay, 3 and 5, and locate the lowest number that is the same on each denominator bar. So in this case, the lowest denominator is 15, right? So then what you do, you slide the fraction 2/5 over until 6/15 lies directly under 10/15. All right, so you just line up those common denominators. All right, and then you can say, oh, okay, to add, I'm going to just add the numbers on the numerator bars. 10 plus 6 equals 16. So there you go. So if we had, what, 2/3 plus 2/5, well, boom, 6/15. You're welcome. To subtract, simply subtract one numerator from the other. So 10 minus 6 equals 4. So the difference or missing add-in is 4/15. Isn't that super cool? I am blown away by how cool this is. This was from a book called by Brad Whitzel. He's actually up at Winthrop, I think. I worked with him years ago, but this is a book I happened to find that I had on my shelf from 2004, apparently. So let me just show you this other one. Fractions reducing. So you have 3/9. You want to place 3 1/6 over 9 1/6. This is his words, okay? So here's your 3, here's your 9. We need to divide the numerator and denominator by the same number of sticks. Let's try by 2. Move sticks together as shown. Since the groups are unequal, then we try to divide by another number, right? So they can see, oh, nope, that wouldn't work. It's not equal. Okay, let's try to divide the numerator and denominator by 3. Move the sticks together as shown. There are now groups without any remainders or any leftovers. One group of 3 over 3 groups of 3. Okay, so here we have now one group of 3 over 3 groups of 3. Stack the 1/6 per group. Okay, so what you're going to do, you would stack up the 1/6 right here and stack up the 1/6, 1/6, 1/6. We are left with 1/3 or 1/3. 3/9 can be reduced to 1/3. All right, so you started with 3/9, right? And then you taught them how to reduce it. How cool is that? I just thought they were awesome. So that's why I wanted to make sure that I included these strategies. Also, make sure to visit your textbook, you know, especially those activities at the end, those evidence-based practices and those instructional activities. I hate that there's only one chapter about math, but that's what we have to deal with. So that is it for chapter 11. I have one more joke for you. Get ready. I had a hen who could count her own eggs. She was a mathema chicken. That's all I got. That's the end of chapter 11.